So let's take a stab at this problem. It says find the equation of a tangent line to the curve generated by the function f of x, which is defined by e to the negative 2x plus x squared, and we want that tangent line to be at the x value of 2. So the first thing we need to do is we need to get a derivative of this. So we need to find an f prime. So dy dx of this guy, let's work it out. Okay, now I'm going to use a chain rule here, so I'm going to make a substitution. I'm going to say, okay, let's just let u, or some variable, whatever you want to use, no pun intended, is equal to that exponent. So what this becomes is d over dx of e to the u. Now, we can't differentiate with respect to x of a function of u. So what I need to do is apply the following. Now this guy I can do. So du dx, we'll get that guy in a second. And now the derivative of e to the u with respect to u is just e to the u. So again, we'll get that du dx in a second, but e to the u, if we go back and we substitute what u was, that's e to the negative 2x plus x squared. Now, for some of you, you might just say, okay, well, look, I know this guy's going to be the same thing, so I'm just going to skip from step 1 down to here. And that's fine. But if you want to provide a convincing argument to someone that that's true, you should go through all these steps. And you should make sure that you can justify every piece. So we have dy dx equal to, now, u prime, or du dx. That, let me do that, you know what, let's erase this. We'll get a little bit more room here. So du dx is the derivative here of this right side. Okay. And so clearly this guy here is negative 2, and this guy here is 2x. So that's what du dx is. So we're going to replace that right here, and we're going to end up with dy dx is equal to negative 2 plus 2x times e to the negative 2x plus x squared. So let's go ahead and continue this. Okay, so let's scroll down here. So here we've got our derivative. Now we want to evaluate it at 2. Okay, so let's just kind of figure out what's going on here. This, what I've got is 2 something is a point on the original curve. So let's take our original function, okay, and let's evaluate it at 2. So what I've got to get the y value out here is that f of 2 is equal to e to the negative 2x. Oops, I got to replace that x with 2. Plus 2 squared. Well, this is e to the negative 4 plus 4, or e to the 0. And so we know that that guy is equal to just 1. So now I've got a point on my graph. If you want to find a tangent line, you have to use the point and the slope. Well, what's the slope? The slope is the derivative evaluated at that x value. So what I need to do is I need to take dy dx and I need to evaluate it at 2. So that's going to be negative 2 plus 2 times 2, that guy, times e to the negative 2 times 2 plus 2 squared. Well, we already know that this guy right here is equal to 1. So this is just going to be negative 2 plus 2 times 2 times 1. And so our slope here, this is going to disappear. Our slope is going to be 4 plus negative 2, which is 2. So what we've got here is we're looking for a line y equals mx plus b. We know that it has this point on it, and it also has a slope value of 2, which is from over here. So that's going to be y is equal to the slope times the x value plus b. What we're trying to solve for is b. That's what we don't know. So to do that, let me do that in a different color here. So this is going to be our y value. It's equal to 2 times 2 plus b. The reason we can insert that, guys, when we're looking at this, is that this line right here, okay, this whole line is a solution for every single point on it, meaning that it holds true for every point. So if 2, 1's a point on it, when the x value is 2, the y value is 1, this guy's got to hold true. It's got to balance. So we'll solve for our b here. This is 4 plus b is equal to 1. So of course b is equal to negative 3. So that generates the equation y equals 2x minus 3. So what we're going to do, this is our answer, we're going to check that using some kind of graphing software. Okay, or we can probably just use something like Wolfram Alpha to check it. Now what I like about the graphing software is at least it gives us a picture here of what's going on. So I'm going to delete these graphs right here and put in our function, which is e raised to the quantity 2x, excuse me, negative 2x, okay, plus x squared. Okay, so there's our function. Now I'm going to graph the line y is equal to negative 2x, excuse me, y is equal to 2x minus 3. And now if I zoom in, okay, if we take this spot right here and we just zoom in at it, sure enough, it looks like at 2, oops, we're stuck there. Looks like at 2, we have found our tangent line. Let's see what Wolfram Alpha gives us. Let's ask it for the tangent line of e raised to the quantity negative 2x plus x squared at x equals 2. And there, Wolfram Alpha has given us 2x minus 3, which is exactly what we said it was going to be, and it also has given us a nice graph here to look at. So we know that our solution is correct.